Okay, so our next topic is sum and difference identities and proofs, and I'm going to go through a series of strategies for the sum and difference identities, and these values are not from our unit circle. They're not common values. So we have to go through a series of steps and set ourselves up to be prepared. So our strategy would be first to draw a reference triangle for the two angles given in the problem, and you need to make sure you put them in the appropriate quadrants. And then we'll label the two sides using SOHCAHTOA. Okay, and we've already done that before, so you should be familiar with that. And then find the missing side by using the Pythagorean Theorem. Or you can use your common triples that we talked about from geometry. Okay? All right, so I'll go through an example that uses all three, whether it's the sum or difference for sine, cosine, or tangent, so that you can see how everything works. So the first piece of information that we're given is two different angles, alpha and beta. And they tell us that the sine of alpha is 5/13, and alpha, meaning the angle itself, lies between 0 and pi/2, which means that this angle is in quadrant 1. So what we're going to do is draw first just quadrant 1, focusing on quadrant 1, and I'll draw a triangle coming out from the center. And we know that sine is y/r, so I'll put my y value here and my r value here. And this is actually a special common triple, so this is 12. But if I didn't know that, I would use the Pythagorean Theorem, using x squared as my unknown plus my y squared value is equal to 169. When I subtract, I end up with 144. I take the square root, and because I'm in the first quadrant, I will use the positive value. Okay? So then what I'm going to do is create a t-table in the middle here. And this is going to give me my values for alpha and my values for beta, and I'll do the beta triangle here. So they gave us the sine of alpha. It's 5/13. The cosine of alpha is my x over my r, which is 12/13. And the tangent of alpha is equal to y/x, so that would be 5/12. Okay, so I'm finished with the alpha triangle. I'll need that later, so I'm going to focus on the beta. So they're telling me that cosine of beta is -3/5, and that beta falls between pi/2 and pi, which means I'm in the second quadrant. Okay, so that's very important because we know cosine is negative there, tangent is negative, and sine will be positive. So I'm going to focus on sketching my triangle in the second quadrant like this. Okay, cosine is x/r, so this would be -3/5, and this is actually a 3, 4, 5 triangle. So I'll put my 4 here. Y's are positive, so now I can go through and identify sine, cosine, and tangent of beta. So sine of beta, cosine of beta, and tangent of beta. This is alpha. Okay, they gave me the cosine of beta, so I'm going to put that in there as -3/5. Sine is y/r, so this would be 4/5, and then tangent is y/x, so this would be -4/3. And remember, it doesn't matter where you put the negative, the whole thing is negative. Okay, so now I have all the pieces to my puzzle. What I do need to remember are my sum and difference for sine and cosine, so I'm going to write that down for my first problem. In A, cosine of alpha minus beta, so that means I'm using the difference formula for cosine, which is the cosine of alpha, cosine of beta, plus sine of alpha, sine of beta. And you will need to know these. I have my alpha and beta angles all up here in this T-chart, so I'm just going to plug in. Cosine of alpha is 12/13. So I put 12/13 in here. I made a full substitution, times cosine of beta, which is -3/5, plus sine of alpha, 5/13, times sine of beta, which is 4/5. So now I can multiply. This is negative 36 over 65 plus 20 over 65. Common denominator, my final answer is negative 16 over 65. Okay, so that's 1. Since I still am using the same two triangles for the sine, I'll come down here. I need to write down the sum formula for sine. So sine of alpha cosine beta plus cosine alpha sine beta. I almost forgot. Okay, so now I need to go up and grab my pieces. So up here, the sine of alpha is 5/13. I make a full substitution. Cosine beta, negative 3/5, plus cosine alpha and sine beta. Okay, because these are coming from the same triangle, my denominators are going to be the same. So what is this? Negative 15 over 65 plus 48 over 65. So that leaves me with, did I make a mistake? 48 and 15, so what is that? 33? Check my math. Okay, in this last one, you have to use the tangent formula, which, remember, is a fraction. So this can get a little bit complicated, but I'm hoping that it won't. So the difference formula for tangent is the tangent of alpha minus the tangent of beta over 1 plus the product. So I need to go up to the top because all I'm using is tangents, and they're right here. Okay, and I'm going to plug them in. So the tangent of alpha from my t-chart is 5 over 12 minus the tangent of beta, which is actually negative, so we're adding 4/3, divided by 1 plus the product of the two, so this will be 5/12 times negative 4/3. So if I simplify this, I'd have to get a common denominator, which my common denominator here would be 12. But when I multiply in the bottom, this is going to be 36. So what I really want to do, if I can, is multiply by 36 over 36, but I'll do that in the next step. So here, my common denominator, I would multiply by 4 over 4. So this is 16 over 12, so that would be 21 over 12 divided by, let's see, this would be 1 plus, actually 1 minus 20 over 36. Okay, so I know I need to get a common denominator here, but actually because I have a complex fraction, it's easier if I multiply this whole thing by the least common denominator. So I'm going to multiply by 36 over 36. So this actually reduces to 3. So what is that? 63. And then here when I distribute, this is 36 minus 20. So I end up with 63 over 16. Okay, you cannot leave your answer as a complex fraction, so you have to get rid of that.